Hey guys, welcome to CS Talks. My name is Chintan, and today we are going to talk about storage capacity estimation. This is one of the most important steps in system design, whether you are doing in real time or in any interview. So why we need estimation in anything? So let me give you an example in real life. For example, let's say I want to make a tea, right? So how I will proceed to do some estimation, basic estimation, and we are already doing in our real life. For example, how many people are going to drink tea? How much milk I will require, how much water I will require, and all those things. So this is a basic thing you try to calculate in your mind before moving forward to making a tea. Let me give you second example. For example, you want to go 60 mile far some other place, and now you want to calculate that how much petrol I need in my car. So what you are going to do is you are going to do some basic calculation that okay, my car's mileage is this, and now I want to go 60 mile far, then I will require this much gallon or this much liter of petrol in my car. So those kind of basic estimated calculations we are already doing in our real life. Exactly same way in system design, there are few aspects we estimate before moving forward to the system design. And one of the aspect is storage capacity estimation. So in any system, like how much storage is required beforehand, before like going to design the system is an important part. So that is why today's topic we are going to learn or like talk how we do storage estimation for any system design. And in system design, we do calculate few things based on the assumptions. So any estimation requires the assumption. So you need to make some of the things like some of the assumptions, and then try to estimate a few things like storage, bandwidth, throughput, and like there are a lot of other things you can estimate. So let's start. Today we are going to go in detail with the Twitter example. So I am taking one of the easy example so that you can understand, and I will make a lot of assumption. I'll tell you what are the assumption I am making. So let's go and check that how a Twitter as a company can estimate their storage for all the tweets. Before moving forward, I want to tell you two important things which you need to keep in mind, so that you know your estimation calculation will be little bit easy. So remember, in this you don't use the calculator, because if you are in interview, you can't use a calculator. And let's say you are in real time, right? So it is good idea to do like rough estimate on paper. So two things. First is always round up the numbers. So round up numbers. Why? So let's say you are in process and you are getting, let's say, 195. It is very hard to calculate the multiplication with 195 without calculator. So in those scenarios, what usually you do is you write like this, equal to, and then this tilde sign, and then you make it 200. So now 200 is an easy number to calculate and do other calculations. So that is first thing. Second thing you need to keep in mind is whatever the assumption you are taking, right? Always take some easy round number assumptions and which are near to real time, so that it will give you a correct magnitude for any problem solving. So let's say, for example, you need to assume that how many users are going to use. So don't assume that okay, I'm like there are 335 million users are there, because now whatever the calculation you are going to do, it is very tough to calculate or multiply with 335. So always try to assume that okay, there are nearly like 300 million or 500 million, or let's say if the application is small, there are like only, let's say, 10k users. So this kind of easy assumption are good for calculating the whole thing, and it is always have some kind of variation, some degree of variation, with the original numbers. But this is again, that's why we give name estimation. So we need to keep our assumptions and all the numbers round and easy. So those two things I wanted to tell you before moving forward to the calculation. Okay, let's start. So just to give you context, Twitter is a website in which people post the tweets and other people can read or see the tweets. And it is a very famous website. And let's start. So first thing is we need to make some assumptions. So always in any application, there are going to be user, whether in the form of customer and or in the form of some other service or application. So you have to always start with, first thing is that what are the total number of users. So first thing is, let's say I'm just writing here in the assumption section that what are the number of users. So here I have done some research, but in general, you can take a number based on the popularity of the website. So I have done some research, and there are around 339 million monthly like users are there. So I'm writing that okay, I'm taking some assumption here. So I'm rounding to 300 million users, right? Now whatever number of users are there, but what you want is the daily active user, because we are going to try to calculate everything based on the day, and then we will go up and calculate for more time span. So every day, how many number of active users are there, because now we are going to go in the trail to calculate and dig deeper. So let's assume, and I have done some research, so there are 155 million around daily active users are there, and those are the people who are increasing the traffic in the Twitter. So that is why the second most important assumption, or you can based on the real time research, you can tell in the interview that daily active users, right? So I am taking, there are 155 million, so I am taking 150 million users, right? So now we have done our first two most important assumptions for Twitter, that okay, we have total 300 million users, daily active users are 150 million. What is the third step in any capacity calculation? So what is the core content of the application? So here the core content is one tweet, right? So that is our core content. So now you will ask that, okay, in Twitter, what is the content size? So usually Twitter have 140 characters, right? Limit for per tweet. And I would say 140 characters. One character is, again, I'm assuming that one character is 2 bytes. It can be different. It can be like 1 byte or something. But for now, for this example, we are taking 2 bytes. We can change in future and we can do the recalculate again. So one character is 2 bytes. So based on that, per tweet, we have 140 into 2 equal to 280 bytes, right? And again, I am taking here approximation. So I am just making rounding to 300 bytes here. So now I know that per tweet, I have 300 bytes. And I'm making, for now, a big assumption is that tweets have no media. So it's just text, simple text. I'm just making this assumption. I'll tell you in the future that how to calculate with media. But for now, no media. So only text. So we have per tweet 300 bytes, right? So now we have one tweet thing ready, and we want to calculate that per day how many tweets we are going to like store, or like how many people are going to create the tweets. So we know here that 150 million users are there, right? And what we can do is, and I have done some research, approximately 500 million tweets per day people are posting. So 150 million users are posting 500 million, fair number, because I have seen there are a lot of news website, news Twitter accounts, and a lot of famous people are putting multiple tweets. a day. So yeah, we are here assuming one more thing, and you can do some research around that. So daily 500 million new tweets are coming. From whom? From 150 million daily active users. So this is our number. Now we have one tweet size and we have total tweets, new tweets. So what we can do is the next step is we have 500 million. So I'm writing here 500 million into 300 bytes. Now I'll show you the calculation how you do in any interview or in real time. Is million is 10 raised to 6. So 500 into 10 raised to 6 into 300, right? Now usually in any calculation you always go with the three zeros. Like whenever you do any calculation, try to group with the three zeros, because with three zeros I'll put in description the link of remembering some easy calculations. So three zeros is why so 5 into 3 is 15, right? And what we can do is here we have 1 2 3 4 extra zeros, so here it will be 10 raised to 10, right? But now 15 into 10 raised to 10, it is very hard. So what we can do here is we can do like this: 150 15 into 10 into 10 raised to 9. So 15 into 10 is 150 and into 10 raised to 9. Now 10 raised to 9 is gigabit. So 10 raised to 6 is approximately megabyte. Then 10 raised to 9 is gigabyte, and then 10 raised to 12 is terabyte. So remember those kind of boilerplate calculations or like things before doing these things. So now I know this is 150 GB. So per day, what I need is for 500 million new tweets, I need 150 GB of storage, right? So now we have one benchmark that okay, daily Twitter company need 150 GB for simple plain text 500 million tweets, right? Now for any company there is a retention period for any new data. So let's say that Twitter is retaining any number of tweets for only 3 years in the main storage, and then they are going to put in any cold storage or something, right? Let's assume that they are only keeping for 3 years for now. So what you can do is here the next step is that we are assuming that they are keeping 3 years in any storage, right? So now we need to calculate that for 3 years how many storage Twitter will require. So it is a simple calculation that we have already 150 GB. So I am putting here 150 GB into, we need to do 365 because there are total 365 days in a year. So 365 into 3. Now what I will do is, this calculation will be tough, right? So I will try to make this easy in terms of that this 365 I will make it to 400. So now my calculation will be easy. I am doing some overestimation, but believe me, when you do estimation, you always do some overestimation because you don't know what will be exact thing, and you don't want to do underestimation anytime. And we need to calculate this thing. So we have 15 into 4 into 3, which is going to be 180, and this 0. So we will keep this 0 here, into we have this 20. So it is 10 raised to 2, into we have this GB. So GB is 10 raised to 9. So now we have this 10. Remember I told you like group 3 zeros always. So this 2 plus 1 3 and this 9. So it will be 180 into 10 raised to 12. And as I told you, like 10 raised to 12 is terabyte. Read those calculations. I'll post it in the description. So 180 terabyte. So here now we have number is 180 terabyte, and in most of the cases companies are doing overestimation, do some more estimation so that they can accommodate all the major changes or traffic and all those things. So 180 TB is required for 3 years to store all the new tweets for Twitter. So this is the number. We came with different assumptions, and assumptions can change. So you have to keep in mind that okay, you have made those assumptions, and based on that, we are doing this. Some major assumptions I have took is one character is 2 byte. There is no media. We are going to use like no picture, no video, nothing, no GIF, and daily active like daily we are getting 500 million new tweets from 150 million active users. So that can those numbers can change, and then this magnitude can change, and this estimation can also change. But now we have idea that okay, if these are the cases, then we need this amount of storage, and you can make a little more easy, like rather than keeping 180, you can keep like 200 TB of storage required for this. So this is how you do for a basic core content for any application, storage estimation, storage capacity estimation. Okay, so in previous part, what we calculated is based on the assumption that we didn't use any kind of media or we didn't consider anything. But now let's extend our example with the media content. So the previous thing was that 500 million new tweets every day and 200 TB we calculated that storage required for 3 years almost, right? So now let's go ahead and we are going to make more assumptions to consider this extension that okay, we are going to use the media also. So how many tweets will have media content? Here I am going to make one fair assumption that 1 out of 100 tweet will have media content. So you can, and it can change. Again, this is assumption, but I'm fairly saying that okay, 1 out of 100 tweets will have media content in the form of either picture, GIF, or video, or any kind of thing, short video kind of thing. So let's consider this assumption and go ahead that okay, we have total 500 million new tweets. So based on that, we will have 500 divided by 100 equal to 5 million per day. So 5 million tweets will have this extra content per day. Now we know that okay, 5 million tweets, right? But then we don't know what is the size of the content. So let's put an assumption that Twitter company put a maximum size for any extra content 2 MB. You can consider anything, like usually it's between 1 to 2 MB or it can be more. But I think the whole idea about tweet is that it should be very less. So they have put that okay, 2 MB content is the maximum size. So I am putting an assumption that 2 MB is the max size of content, right? So we are going to calculate based on this assumption that one content will be maximum 2 MB size, megabyte. So now we just need to calculate that per day how much storage we are going to require for this extra media content. So it will be 5 MB into 5, I'm really sorry, 5 million into 2 MB, right? So how we are going to calculate? It's very simple. 5 into million is 10 raised to 6 into 2 into megabit is also 10 raised to 6, and we are going to do is 5 into 2 is 10 into 10 raised to 12, right? So 10 raised to 12 is TB. So 10 terabyte per day we need extra for this media content. Now just to give you one idea, whenever you have MB, million, and you are calculating with megabyte, it will always give you answer in terabyte. I'll tell you some short tricks to calculate fast in future. So here you can directly say is like 10 terabyte per day, right? So now we have per day calculation ready. And as in previous example, we took that okay, Twitter is keeping everything for 3 years. So what we can do here is we extend our calculation to 3 years into 1 year have 365 days into we have 10 TB, right, per day. Now, as I told you previously, like we are going to make this as 400 to make our calculation easy. So I'm taking it 400, and we are going to do some little overestimation, but that is fine. So 3 into 3 into 4, 12, right? So 12 I'm going to do, and then I have 1, 2, and 3 0. So I'm keeping that 3 0 as here like this. Into I have terabyte, right? So 10 raised to 12. Now 12 into 12 plus 3, 15. So I'm keeping here 15. So 15, it's petabyte. So 12 petabyte we require per 3 years here, right? So remember this number. So we got for media content per 3 year we need 12 petabyte of storage to store this kind of media content, which have maximum size is 2 MB. So now our previous number is this for tweets 200 TB. From that we have made some assumption that okay, 1 out of 100 tweet will have media content. So 5 million tweets will have some extra content apart from tweet, and one content will be maximum of 2 MB size. So that is how we calculated that 10 terabyte per day we need extra storage, so that if we calculate for 3 years it will be 12 petabytes of extra storage we require for media content. So this is how we extended our calculation with considering the media content. So now we calculated for core tweet content storage space, we calculated with media content storage space, and one thing we missed is that what about the metadata? So any data in any application always have a metadata and all other supporting tables. So I have decided to go through one metadata table here, but I'll tell you what are the other tables you need to consider in this Twitter kind of example. So let's go ahead. We have first result is 200 TB per 3 year per tweet, 12 petabyte is for media content, and now we are going to calculate for Twitter tweets metadata. So usually tweets have this kind of table structure, or any kind of storage you store data like this. That tweet will have a tweet ID. This is going to be like primary key. Then who posted that tweet? So it will have user ID, right? When it created, so it will have created on time, created on, right? And then fourth thing is like whatever the tweet text, and means text we already calculated here. So I could have done this thing, all this calculation in the first one, but just for to make a generalized format I did like this, because in all other kind of applications and websites it is good idea to calculate the metadata as a separate and core content as a separate calculation. So just to make that more convenient and generalized I did like this. So text, and if it has media content, then media content path or something, media content, right? So this kind of format we'll have. Now in this and this we have considered, but these three we forgot to calculate the storage, right? So now we are going to calculate for these three metadata storage calculation. Again, same way, we just need to go from very basic to increase the numbers. So tweet ID, usually any kind of ID or primary key have 8 bits, 8 bytes, sorry. So it is like a long number, so the double basically. So you can use 8 bytes number. Then user ID also have usually 8 bytes. So I'm keeping it user ID as 8 bytes for now. Then created on date time mostly have 8 bytes. So I'm just keeping it 8 bytes here for the make the calculation a little bit easier here. But yes, user ID is one thing, can be variable. So let's say if user ID is in the form of some other kind of characters, then it can go up to like 32 bytes or more. So here I am just using that user ID will be an integer 8 byte here. So that is my one of the assumption here. So now we know that we have total for per tweet 8 into 3, 24 bytes of metadata per tweet, right? So now we have per tweet metadata size ready. And just for the, as I told you, right, I usually make the assumption round. So I don't want to make this 20 bytes because it will be under assumption. So I'm making this as a 30 bytes of metadata per tweet, right? So now we know that per tweet we have 30 bytes of metadata, and same way we are going to calculate that we will have 500 million tweets per day into 30 bytes, right? So what we are going to do is 5 into 3, 15 into 10 raised to 3, these three numbers, and then million have 10 raised to 6. So it will have 15 into 10 raised to 9, right? It is going to be, because it is 10 raised to 9, it is nearly called as GB. So 15 GB of data per day we need for metadata. So now we have rough estimation that 15 GB per day we need for metadata for all the newly created tweets. And now what we are going to do is, as we are calculating everything for 3 years, what we are going to do is, 15 GB into 400. As I told you in the previous example that for 365 days, I am making 400 as a round number, and into 3 years, right? So now 15 into 4 into 3 is 180, into GB is 10 raised to 9, into, we have these two numbers extra, so 10 raised to 2. So what I'm going to do is, now this 1 and this 2 is 3, so we will have 18 terabytes of I think, yeah, 9 and 1 2 3, yeah, 10 raised to 12, so 18 terabytes of data per 3 years for metadata. So now we have metadata storage estimation also, that for all the 500 million new tweets per day, in compared to 3 years, we need total 18 terabyte of data, like storage space required for all the metadata of the tweets. Now we calculated the metadata for tweet table, right? Like whatever, wherever we are storing the tweet, we calculated the metadata for that. But now what we have missed is all other different tables. So that is something you can do it as a part of the homework. That okay, you like here we have used the user ID, right? So now user table will be there. So what is the capacity estimation for user table? You need to do it by yourself, and post in the comment if you don't find how to calculate. I can help you to do that thing. So just remember, we took 500 million new tweets, and in the first like if you go back in the video, 150 million active users we have, and total 300 million users are there. So based on those numbers, you need to make a user table, you need to estimate all the user metadata sizes, and then calculate the user table storage requirement. So that is your homework. You need to do that by yourself, so you will get confidence around that. So yeah, and all other different tables. Let's say you have different other tables which you are using in this Twitter application. You have to calculate those estimations also and add up in this number. So now we have three numbers: 200 TB, 2 MB, 12 petabyte, and then it is 18 terabyte. Now this 12 petabyte, right? So what I can do is, we need to now calculate the total number of storage, total size of storage we need, right? So what I can do is, let me just erase this part so that I can do a calculation here, right? So what we can do is, we have 200 TB, so total equal to 200 TB plus we will have 12 petabyte, right? Now 12 petabyte is how much terabyte? So you can say that it's a 12,000 terabyte plus we need 18 terabyte here, right? 18 terabyte. So now it will be we can say around, let's calculate this 200, so 218, so 12,218 terabyte of total space per 3 years required for Twitter. So 12,218, and you can make this as like 12.2 or around 13 petabyte or something, 13 petabyte around. So let me just make it 13 petabyte. So I'm just making here like little overestimation that okay, we need approximately 13 petabytes of data, storage per year to do all these things like storing tweets, storing their media content, storing their metadata. And if you are adding user, then we need to add some more size here. So this is how you do the storage capacity estimation in any real-time problem, system design problem, or in an interview. Now I showed you here a very in-depth, in detail way to calculate the storage. But when you are in an interview or in real time even, and once you are very comfortable with these things, you will spend hardly 5 minutes or like I would say 3 to 5 minutes uh, in this calculation. Thanks for watching my video, guys. And please do check out all the links, resources, and tricks in the description below. And please like and share my video. And if you have any feedback or concern, let me know. I'm happy to talk about that thing. And let me know any new topic suggestions. I'm happy to make new videos around that.